Welcome. Today we present an analysis of the Superhetrodyne FM receiver. This technology remains a standard in radio communication. But what does the name mean? If we break it down, super means high, hetero means different, and dyne refers to mixing. Put simply, it is a technique of mixing two different frequencies to produce a new fixed frequency. This process converts incoming radio signals into a fixed intermediate frequency, or IF, allowing for higher selectivity and much better stability than older radio designs. This presentation explores one of the most fundamental architectures in modern telecommunications. While we often take radio for granted, the technology inside your car stereo or portable radio is a masterpiece of engineering. It solved a massive problem that plagued earlier wireless communication: the inability to cleanly separate one radio station from another. To understand the solution, we must first understand the problem. In the early days of radio, engineers used what was called a tuned radio frequency, TRF, receiver. Imagine trying to tune a guitar where every time you wanted to play a different note, you had to retune every single string perfectly. That is how TRF radios worked. If you wanted to switch stations, you had to adjust multiple filters simultaneously. It was difficult, unstable, and often resulted in radios that could not distinguish between two stations that were close together on the dial. This led to the invention of the Superhetrodyne receiver. The brilliance of this design is consistency. Instead of processing the signal at whatever frequency it arrives at, this system converts every incoming signal to a single, fixed frequency before processing it. This concept revolutionized radio. Let us look at the heart of this system. Here is the step-by-step journey of a radio signal. First, the antenna captures the weak frequency-modulated FM signal from the air. Second, the signal enters the RF amplifier, which boosts it slightly. Third, and this is the most critical step, the signal enters the mixer. The mixer is connected to a local oscillator. As you turn the tuning knob on a radio, you are actually changing the frequency of this local oscillator. The mixer takes the incoming radio frequency and the local oscillator frequency and smashes them together. This mathematical multiplication produces a new frequency known as the intermediate frequency, or IF. For FM radio, this standard IF is 10.7 MHz. Why is this important? It means that whether you are tuning into 88.5 or 105.1, the rest of the radio only has to deal with 10.7 MHz. This allows engineers to build extremely precise filters that block out static and noise because they only have to work for that one single frequency. It passes through the IF amplifier. This stage provides most of the signal gain and creates the selectivity of the radio, its ability to ignore the station next door. Finally, the signal reaches the demodulator. Its job is to decode the wave. It converts the rapid frequency shifts back into audio voltage, recovering the original sound. This weak signal is then boosted by the power amplifier to drive the speaker. Thank you for your attention.